entropy and write the maximum for the entropy. Take a derivative of that. For example, take the logarithm from this, use the Stirling approximation, and take the derivative. Your parameter here is ni. So I write delta s, I mean partial derivative of this with respect to ni should be 0. So what you will do is that you take the logarithm from this, for example, from the boson I will do, just to see. So I will find, for example, for boson, I will find the entropy. Entropy will be sigma I ln gi plus ni minus 1 factorial minus ln ni factorial minus ln gi minus 1 factorial. For each one, you remember one time I told you that using the Stirling approximation is easy but not always correct, because some of the state of may be occupied just by 2 particles. I mean sometimes gi is just 2. So ln2 is 2. No? You cannot use the Stirling approximation. But is the it's okay, but it's not almost correct. The correct way is that to use the method of the generating function or use the complex variable methods. A stable descent method, but we didn't use that in the complex plane. Because we don't know that, and I don't want to spend the time to explain that. We use the Stirling, so Stirling x factorial is just x ln x minus x. So will be kb sigma I gi plus ni minus 1 ln gi plus ni minus 1 minus gi plus ni minus 1 minus ni ln ni plus ni minus gi minus 1 ln gi minus 1 plus gi minus 1. Yeah. So now, do you know what you need to do? This is the S. You need to make the delta S delta Ni. Partial derivative with respect to Ni. Do you want to do that? I think you can do, but because this question and one more question I want to give you as a homework for the next homeworks. You will have 1 or 2 more homeworks, and that will be all. So, if you take it that, I want to tell you that the Ni will be I can write it that, but I want you to do that. If you write, we can write it. You can find delta Ni. So I want to tell you that if you do this variation, it will be like that. It will be something delta Ni 0 for the Ni equal to Ni star on the maximum, which will make the S entropy maximum. Exactly the peak here. This can be Ni star, or as I told you, it can be E bar, the maximum. So with that you can find the Ni, and from here you can find anything. So, but I wanted to keep it this for the next lecture because maybe it was better if also we, from combination on is okay, just changing the number of particles and counting 1 factor, 2 factor, 3 another way, and this is it comes from here. For example, look at that. I want to find that. What is this? Yes? The binomial. Look at that. This is very the same as this. What is that? The interpretation. What is the interpretation of this? This is the weight of the state which X is occupied by K and Y occupied by the rest. Huh? You know, the statistical mechanics change it must change your way of thinking about the equations. So this equation for me means that we have a two-state x, y, and that it is occupied by K, and this is occupied by n minus K. Huh? And this is the number of the possibility which I have here, the weight of this state. The weight of this situation is that. Okay, what is this business to you? The business is that except instead of the two, in a statistical mechanics we have several energy states like x1, x2, x3, x1, x2. And you want to, each one is like what I told you. You want to find the weight of the distributing G1 number of n1 particle to this energy, n2 particle to this, and n particle to that. These factorials I want to just make just for you one things to think that. These factorials are related to each other. If you can understand these as a weight of the distribution, n particle between two states, and put it the n k particle here and n minus k particle, this is the number of the possibilities you have. Number of this. It's exactly the same as this, as a mean. But here the situation is more complicated. You have one more index here, because you have more than two variable here. I want to leave it for you. I want to you go and think that how you can, it's written in the book, how you can find this expression by thinking like me here. Just take x like this as a binomial theory, binomial expansion, and think about the W like the weight of the distributing of the number of the particles between the different. So this is a very interesting thing actually. And if you have you needed one more mathematics. The things which you need from the mathematics is that, I don't know that you see that this or no. For example, if you want to write that, do you know how to write that? Huh?